So for SP1a, the first thing we're going to do is chapter 1. And the first part of chapter 1 is 1a, vectors and scalars. Nice and simple. All you need to know is the difference between the two. So you have vectors and scalars and the different quantities. So for example, what are vectors and what are the examples of vectors, and then what are scalars, and can we have a few examples of scalars as well. So a vector is a physical quantity with size, sometimes known as magnitude as well. So if you see the word magnitude in your exam, that just means the size. So for example, the magnitude of the speed of a car is 20 miles an hour or 15 meters per second. So the size is just the value, all right? And that's the magnitude. But a vector also has direction. So not all quantities have both size and direction. Vectors have a size and they have a direction as well. Some examples of vectors then: velocity. Velocity is just the speed, which we'll look at in a second, but velocity is a speed. So for example, a car might be traveling down a road with 20 miles an hour, but because velocity is a vector, it also has to have a direction associated with it. So if I say the velocity of this car is 20 miles an hour, I have to say in which direction. So an example of a vector velocity could be this car is 20 miles an hour to the right or to the left, or it could be north, east, south, west. In an exam it could be positive or negative. So a vector means that it has a size, which was the 20 miles an hour. That was just the magnitude of the velocity, but then I gave a direction as well. So velocity was 20 miles an hour north, 20 miles an hour east. All right. Other examples are displacement. So displacement is just a distance but in a given direction. And the key thing to note about displacement is that you start from the beginning and you finish at the end point of a journey in a straight line. So for example, displacement is a distance. So if I say, right, how far is it from here to here, point A to point B, then the displacement could be 20 meters, which is the size or the magnitude. So 20 meters, but north in a specific direction. Or I could say the displacement is 15 miles east in a different direction. All right. Again, it's really important to know with displacement that you start at the beginning, point A, and you could go on a journey of, let's say, 200 kilometers. You could do a journey for 200 kilometers, up hills, down hills, turn left, turn right, go all the way around. You started at point A, you went all the way around 200 kilometers, and you finished at point B, which is just 2 meters away. Then your displacement from A to B in a straight line is simply 2 meters. It doesn't matter what journey you took or how far you went in between point A and point B, the displacement from A to B in a straight line is 2 meters. Interestingly as well, if I leave the house in the morning and I go on my journey to work, I go up the road, I go left, I go up a hill, down a hill, over a bridge, I take my entire journey to work, and then I come all the way back. The distance I may have traveled on that journey is 20 miles to work, 20 miles back, but because I finished at my home where I started, my displacement for the journey there and back to the same position is 0. Okay, because it matters about the direction. Distance, obviously, this has no direction. Distance is a scalar. So distance was 20 miles to work, 20 miles back, total distance of 40 miles. But my displacement from a starting position there and back, if I finish at the same position, then my displacement, which is a vector, is 0. All right, so displacement is in a distance in a straight line from A to B, and it has a direction, so it's a vector. Distance is a scalar, it's simply how far do you go. All right, other vectors, we have acceleration, which is changing speed, and we're going to look at that later in this chapter. Momentum is a vector. Again, we'll see that in chapter 2. And force, any force is a vector. If you apply a force on an object, so you want to push it, then the direction of the force matters. If I push an object that way, the object should move that way. Okay, so force, any force. Weight is a force, which is a vector, always acts down towards the center of the earth. You have contact force. Friction is a force, and again, it always opposes the motion, so it tries to resist the motion. So any force that you can think of has to have a direction associated with it, which means that it's also a vector. So vectors are any quantity that have a size and a direction. Velocity, displacement, acceleration, momentum, force. A scalar, on the other hand, is simply all of those quantities but they don't have a direction. So any quantity with size or magnitude only. Examples are speed. If I ask you for the speed of an object, you say 10 miles an hour. I don't care what direction, just 10 miles an hour. That's just the size. Distance, how far did you travel? 20 meters? I don't care which direction. Okay, time, 10 minutes. Time doesn't have direction, it is simply just a value, it's just a number. Mass, in kilograms. So what's the mass of this object? 10 kilograms. I don't care about the direction. If I take mass, which I then go to weight, which is a force, weight is a force, so a vector, which always acts down. So mass, simply how much mass do you have? In kilograms, no direction. But force, which can be converted into weight, is always downward, so it's a vector. Energy is in joules, no direction, just a size. Power, also the same, it's energy in time, so they're both scalars. And finally, temperature, if you want to know the temperature, you might say 20 degrees Celsius. Again, there's no direction when it comes to temperature. So vectors, size and direction. Scalars, size only. All right? Something else you need to know for this first part of chapter 1 as well are the units of all these quantities. So we literally just had a list of different quantities so far that we might know in physics. There's a lot more to come in every chapter, but every time we learn a new quantity, we have to associate a unit. And the unit just means, what do we measure this quantity in? So for example, speed and velocity. We know that speed, for example, is 10 miles an hour or 25 kilometers an hour or even 10 meters per second. So they're all units that we can measure speed and velocity in, but we have to choose a standard unit that we use in science across the world. So all the countries are using similar things. That's not the case all the time, but at least if we have a standard unit for our calculations and our equations, then we're not going to make silly mistakes. So speed and velocity, the unit is meters per second, m/s or m/s. Distance and displacement, because remember displacement is just the vector of distance, so it's distance in a certain direction. So distance we measure in meters, so the standard unit of distance is meters. Time, seconds. Mass in kilograms, not in grams. So a lot of students make that mistake and they try converting kilograms to grams, but mass actually has the kilo in front of it, so it's kilograms. We'll talk about the prefixes later. Force is in newtons, so always in newtons. Energy is in joules. Acceleration is in meters per second squared. We'll see that unit later on. Power is in watts, capital W. Weight, we said weight is a force. Really common misconception that people think weight is in kilograms. Weight is a force due to gravity, so the unit of weight is newtons. All right? Work done is also energy. You'll learn that in chapter 2 in stopping distance. The work done unit is joules because it's energy transferred. And then momentum is the mass of an object times its velocity, so it's kilogram meter per second. So they're the units of all the quantities that you'll probably look at and see in this chapter. You need to make sure you remember the standard unit that we're going to use. The reason that it's important to know those standard units is because some questions in the exam, when you're doing a calculation and you have to use this value, they may come with what's called a prefix in front of their unit. Now, perfect example would be if I said the force on this object is 20 kilonewtons, then it would have the K next to the newtons. Now, it won't say kilo, it will just say Kn. So you need to be aware that all of these conversions and prefixes are just symbols. You have capital G, M, K, small c, small m, mu, which is a Greek letter M, but in the exam generally they will actually write the word micro. So they don't expect you to remember this symbol, but it's worth remembering just in case. And N, the small n for nano. So we have giga, mega. You will have probably seen giga in gigabytes, which is storage for memory. All right, but you could see giganewton, gigahertz, gigawatts for power. Mega, kilo, centi. You've seen it plenty in centimeters. Milli, micro, quite rare that you've seen that at this point, and nano as well, obviously prefixes that they're going to start using. These are the ones you have to know for the GCSE physics. All of these, G, M, K, C, M, mu, and N for nano. Now, if you get a question in the exam, let me just write, let's say the power equals 10 gigawatts. Now, they would use the word power in the question, so you know it's a power, but just in case they don't, it says 10 GW. Now, you're expected to know the units of power at this point, so you know the W represents watts, but the G, you should remember from the prefixes that G is giga. Now, how do I turn that into an actual value to use in my calculation? because a lot of students will just put power is 10 and put it into their calculator, but you will lose 1 mark for not converting this correctly. So G, you should know, and all these prefixes, we just use standard form, which you will have done in maths, and we use times 10 to the power of some number. Now, all the big numbers, so giga is a big number, giga, mega, kilo, they're your big numbers. So giga is times 10 to the power of 9. So in your calculator, all you would do in the exam is write, okay, let me convert this 10 times 10 to the power of 9 watts. And that's converted. There's the 1 mark you've got straight away for converting. Now you can use this value in your calculation and you won't lose that mark for not putting the conversion of giga in there as well. So giga is G times 10 to the 9, mega times 10 to the 6, kilo is times 10 to the 3, centi, now we're in the small numbers, so we're actually making smaller numbers different. So centi is 10 to the minus 2, milli is times 10 to the minus 3, micro is minus 6, and nano is times 10 to the minus 9. Really easy to remember that they go 963 minus 2 minus 369. The only one that doesn't fit that 963 minus 3 minus 6 minus 9 is the centi. Alright, so if you remember them in threes but just the centi is minus 2, then you shouldn't make a mistake. So you have to recognize it in the exam. GW is gigawatts. Giga is 10 to the power of 9. Now I've converted, I won't lose that mark. Alright, so you have vectors and scalars, you have units of your quantities, and then prefixes, which are your conversions for your calculations, which you absolutely cannot get wrong. Alright?